Okay, grab your note packet for 1.4 absolute value. Remember, you've dealt with absolute value in the past. The definition is right here: a distance from a point to zero. So the absolute value of negative 4 units from zero. The Since distance is always positive, you're basically going to get a positive number for whatever you're taking the absolute value of. But we have a few rules that we have to follow, especially when solving equations using absolute values, which we'll work on now. First thing, absolute value as a grouping symbol. The biggest thing about this is you can't distribute into an absolute value. So if I take and I substitute in negative 4 for x, I'm taking it right over from here, plus 2 minus 2, negative 4 minus 3. The biggest thing here, you can't distribute into absolute value. Oops, that should be a straight absolute value line. Now we simplify everything like a grouping symbol inside the absolute value. So I get the absolute value of negative 2, negative 4 plus 2, minus 2 times the absolute value of negative 7, which gives me 2 minus 2 times 7. So now you take the absolute value. 2 minus 14 is negative 12. There you have it. So make sure you do not distribute into an absolute value. Since the absolute value of a variable, we're answering the question, what could it be? So we're saying, well, x could be negative 3 or x could be 3. So the fact that you start with that once you have an absolute value, we're splitting it off into two things. The absolute value of x could be positive 3 or negative 3. We have to keep in mind that it could be the negative side of things. So when we solve equations, we have a couple of rules we need to follow. The first thing we're going to do is we're going to isolate the absolute value. So in terms of steps, step 1, isolate the absolute value. That means to get by oneself. Right now, this is already by itself. Remember, we said we can't distribute into it. So if we had other operations, we'd have to move them first. 2, we're going to rewrite into two equations. One of them will be positive and one negative. And then we always want to check our work. And we'll talk about set builder notation and graphing in a minute. So the absolute value is isolated, and I always kind of just like to do, well, the first one's going to look exactly the same. What's inside here could be equal to positive 4. If what's inside there is equal to positive 4, then we take the absolute value of 4 and we get 4, so we're good. And then the other one, it's kind of like or x minus 3 equals negative 4. Because if what's inside there is negative 4, you take the absolute value, you get positive 4. So you have to keep that in mind. You're kind of you're extracting what's inside there, and then you're solving. So now I add 3 and add 3. X is 7 plus 3 plus 3. X is negative 1. So I have two answers. X is 7. X is negative 1. Plug them back in here. 7 minus 3 is 4. Absolute value of 4 is 4. Negative 1 minus 3 is negative 4. Absolute value of negative 4 is 4. Number line, just plop a negative 1 down, plop a 7 down. Those are my two values. Set builder notation, perhaps something new. I'm going to do it up over here so you can see a little better. We do chicken lips. Those are braces. Set of all x's such that x equals 7 or x equals 1. chicken lips, and we're done. So you're basically putting your answer in here. This vertical line is replacing the words such that. And you read this, the set of all x's. Set notation has braces around the back of it. I like to call them chicken lips because they look like chicken lips, if you know what chicken lips look like. Set of all x's such that x is equal to 7 or x is equal to -1. We can just list them. We'll be using set builder notation for a little bit yet. Next one, isolate the absolute value. That's done. Then you rewrite it into two equations. I always like the first one to be exactly what you see. X plus 5 is 6, because if this is 6, I'm good to go. And then I can say, or x plus 5 equals -6. And then I could have a -6 in there, and I would take the absolute value, and I'd get 6. Subtract 5, I get 1. Subtract 5, I get -11. Plop a -1 on, plop a -11 down. That's graphing. Set builder notation, set of all x's, such that x equals 1 or x equals -11. Chicken lips, do the best you can with the chicken lips, and you're good to go. Check your work. 1 plus 5 is 6. Absolute value is 6. -11 plus 5 is -6. Absolute value works. Having a good time now, aren't we? Oh, look at that. Okay, I got a negative sign here, so we got to watch out because an absolute value is equal to -2. Now, this is where checking your work is a big thing, because some of you may be sitting there thinking, how in the world can an absolute value be equal to a negative? If a distance is always positive and the absolute value is equal to a negative, this is impossible. But let's say you were a good little student and you said, okay, I'm going to do exactly what he said. I'm going to set it equal to this, and I'm going to set it equal to the opposite of it. And I solve, and I get 2, and I solve, and I get 6. And now I go check my work and watch what happens. Put the 2 up in here, and I get 2 minus 4 is absolute value of -2 equals -2. 2 equals -2. What? That's not true. That's not true. 6, same thing. 6 minus 4 equals -2. 2, no, 2 is not equal to negative. Doesn't work. So even if you don't catch it right away, you should be kind of taking a look and seeing, okay, is this reasonable? How do I have an absolute value equal to a negative? It's impossible. But if you check your work, then you'll be able to figure out that, well, it actually doesn't work, and we say no solution. The no solution symbol is a 0 with a line through it. That means no solution. Nothing will satisfy this. There's no way I can take an absolute value and get it equal to a negative. Okay, so now we've got a little bit more going on. We have more than one variable. So the first thing is I cannot distribute into the absolute value. That is very important. So what I want to do to get the absolute value by itself, I need to divide by 3, divide by 3, divide by 3. Need to divide everything by 3. Then I'll have the absolute value of x plus 6 equals 3x minus 2. Now, this thing could be equal to the positive of this, or this thing could be equal to the opposite of this. So we're going to rewrite it into two equations, and we're going to have, I'm going to put one right here, x plus 6 equals 3x minus 2, or what's inside there, x plus 6 could be equal to the opposite of 3x minus 2. Now I solve them both separately, and I would maybe subtract this over here, subtract that over there. So x minus 3x, I get -2x equals -2 minus 6, -8. I get x is 4. I'm going to leave that there. We'll check it in a second. Let's go over here. Distribute the negative sign. remember it needs to be applied here and here. Negative 3x plus 2. Add this over, subtract that over. I get 4x equals negative 4x is negative 1. You got to go up here and check these, especially when there's multiple variables. Things can go haywire in a hurry. Put the 4 in here. 3, absolute value of 4 plus 6. I'm going to just go ahead and do that. Equals 9 times 4, 36 minus 6. 3 times positive 10 is 30 equals 30. This one's good. Yay. Jump for joy. Check the negative out. Watch what happens with the negative. 3 times the absolute value of negative 1 plus 6. Negative 1 plus 6 is 5. Equals 9 times negative 1, negative 9 minus 6. 3 times positive 5 is 15, equals negative 15. Is that true? No. This one, it's called an extraneous solution. First 5 letters of the word extraneous is extra. Therefore, the only solution is x equals 4. You cannot assume with absolute value that everything's going to work out okay in the end. Graph. This is a tough one. 4. Nice job. Set builder notation. Chicken lips. Set of all x's such that x equals 4. Just a fancy way of saying x equals 4. There we go. Check your work. Another one. Do not assume, since it's equal to a negative, that it's no solution. It's equal to a negative. You need to isolate it first. We need to minus 5, even right here, negative 3, absolute value of 2 plus 2w equals negative 12. It's still equal to a negative. Do not assume that it's not going to work, because the first step, remember, is isolate the absolute value. I'm not allowed to distribute into it. Absolute value of 2 plus 2w equals positive 4. Now we split it into 2 equations. 2 plus 2w could be positive 4. 2 plus 2w could be negative 4. Remember, when I rewrite, I'm really pulling this out and saying, what could this thing be? We do not write the absolute value symbols after we pull it out. Subtract 2, I get 2w equals 2. Subtract 2, I get 2w equals negative 6. W equals 1. W equals negative 3. Check your work. 5 minus 3 times, if I put the 1 in there, 2 plus 2, that's the absolute value of 4, is 5 minus 12 equal to negative 7? Yep. Now put the negative 3 in there. Put the negative 3 in there. So I get 5 minus 3 times 2 times negative 3, negative 6 plus 2, negative 4. Well, that's going to be a positive 4. 5 minus 12, negative 7. They both work. They are both a solution. W equals 1. W equals negative 3. Good stuff. Okay, let's continue. And I'm going to move on here. And we're going to talk about how distance is calculated. What we're going to do is, if these are the solutions, we're going to say x minus the central value is equal to the range. And we're going to have to write some of these things. So here we go. If these are the two solutions that you're given, 5 and 7. So you're given that x equals 5 and x equals 7. The first thing I want to do is, what's halfway in between? Halfway in between is 6. If you're not sure, the central value you can get by adding them together. You find the average of them. 5 plus 7 divided by 2, 12 over 2 equals 6. Obviously, this one was very easy. And then the range is the distance from the central value to the points. So the range here is actually 1 unit and 1 unit. Remember, distances are positive. So my x minus 6 equals 1 unit. Now, you can always check it by solving. You would split this up now. X minus 6 equals 1. X minus 6 equals negative 1. Add 6, x is 7. Add 6, x is 5. This is how you would write it. This is going to be your key to writing an absolute value equation. Find the middle value, figure out the range. Write the absolute value equation. Sailors use a laser finder to determine distances. Suppose one rangefinder is accurate within a half a yard. If a sailor is measuring the distance to the shore as 323 yards, what is the range of distances to the shore? First thing we want to do is we want to write the equation. So I'm saying the central value is the 323.1, and we are accurate within a range of a half. So you would say x minus 323.1 equals a half. X minus 323.1 equals negative a half. X equals 323.6. X equals 322.6. There's my range of values. It's between 322.6 and 323.6. We have a central value, and we're accurate within a half a yard. And we're done. So now you can do your 1.4 homework. It was a good time.